Hello, so my name is Jad. So for our research, we're going to be going over the shear strength of lightweight concrete and how GFRP blend and meshes in with it. So a little introduction about lightweight concrete. So lightweight concrete uses lightweight porous material and lightweight aggregates. As the name suggests, it's lighter in material, so that makes it very easy to transport, so it will have less carbon footings. That way, it also has a benefit on the environment. And so a little introduction for GFRP. So what's GFRP? It's a glass fiber reinforced polymer, which is it's a replacement for steel rebars that we're going to use. It acts as lightweight alternative to steel rebars. It is commonly found in bridge decks, marine structures, and parking garages. So GFRP is usually commonly used to restore existing structures with corrosion when corrosion occurs. But for this purpose, we wanted to mention GFRP because of its lightweight, to maximize of how much weight we can make. We can
Reduce.
how much weight we can reduce to maximize being at lightweight. So the objective is to investigate the impact of GFRP, evaluate the shear strength while maintaining its structural strength, to validate and refine design codes. So the significance of lightweight concrete and its environmental impacts. Some environmental impacts, it would be a global warming potential, acidification, vitrification, and photochemical ozone creation potential. And by using lightweight concrete, we would greatly reduce the impact on the environments. And then some of the economical benefits is that lightweight concrete would also cost less to produce than normal weight concrete. And it also, since it has better workability, it will require less labor. And so it also has reduced dead load, which pretty much makes it faster for handling and transportation. Also, since we're using lightweight aggregates, it's more suitable for high seismic risk areas, and also has improved insulation. So some structures that we found that use lightweight concrete instead of normal weight concrete is the Bank of America building in Atlanta, Georgia, and the 150 North Riverside, Chicago, in Illinois. These two buildings switched to lightweight concrete, and they saved about $1 million for it to be built. They also went down in load, which saved them about 13,000 pounds and 14,000 pounds. For each of these buildings. So the advantage of GFRP is corrosion resistance. It does not rust, while steel rebar rusts over time. So this is an alternative that we found, which is better for long runs. It's also lightweight, which is 75% lighter in material than a steel rebar. It has high strength to weight ratio. It has a longer service life, and there's no need for coating or special treatment when you have to place them in the concrete itself. So this is really
Hi, my name's Brendan. Some advantages of using GFRP in lightweight concrete is because both lightweight concrete and GFRP are lighter than normal weight concrete and steel rebar, it reduces the structural dead load pretty significantly. With the GFRP being rust resistant, there's no corrosion that occurs, and that leads to it making it better for being in marine structures or dealing with areas with high amounts of water. And they're both, being lighter makes them easier to be worked with and easier to transport, because you don't have to deal, the workers can carry more at once, so it improves the efficiency, or just carrying it at all is a lot easier on the laborers. Lightweight concrete is better for thermal insulation. Because it's lighter, it's got an increased seismic performance, and it allows it to be more eco-friendly, as we talked about earlier. So the material we used for our lightweight concrete, we used expanded shale, and so we made two beams of each lightweight and normal weight concrete. So we used the lightweight concrete used with expanded shale, and then the normal weight concrete was just cement, like Portland cement, and we used GFRP number 3 bars for our beams. So they both had pretty similar compressive strengths when we did our initial testing, but our lightweight concrete was about 20% lighter than or less dense than the normal weight concrete was. So here's our test setup. So as you can see, the beams had the same dimensions, and you can see the compressive strength of each, and that's the look of our design with the two number 3 GFRP rebars. So here's what the test looked like in action, and you can see our shear failure on that left or right side. And here were our results. So the darker green is the lightweight concrete, and as you can see, it wasn't quite as strong as you'd expect, but once you offset the amount of load that'll be on it, it'll factor into how much it can hold compared to the normal weight concrete. So the purpose of us doing this was we're trying to find the reduction factor lambda that's used for lightweight concrete, because currently in the ACI code, it has lightweight concrete with steel rebar you can calculate, and you can calculate normal weight concrete with GFRP. So what we're trying to do is find with normal weight to lightweight concrete with steel rebar, there's a reduction factor that you apply when you switch to lightweight concrete. So what we wanted to find was what that reduction factor would be if we were doing GFRP. And we found that to be 0.76 based off of our tests. So in conclusion, we found the 0.76 to be our lambda is what we call it, and basically we need to do a little more research because we want to try it on large scale structures, and then we also want to try different size GFRP bars so that we can see what effects those will have on that lambda number. That's just our references.